Hello everyone, I am Rupali Shevade from MVP KBT's College of Engineering, Department of Computer Engineering, Nasik. So these are the course objective of DED subject, course outcome. So in third unit, we are going to study the design and implement the sequential circuit. Before that, we finish with the combinational circuit. So combinational circuit, already in the last topic we discussed about the BCD adder. Now we'll discuss about the multiplexer combinational circuit. So multiplexer is a combinational circuit. So what is the advantage of multiplexer, how we can use that multiplexer IC for the implementation of any combinational circuit, we will discuss very soon. So multiplexer is a combinational circuit. It handles the multiple data input and it has only one output. See, this is the general block diagram of multiplexer. So it has n number of input, that is data input from D0 to Dn, and Y is the output here, and enable strobe is the enable input here, and the select input M is the select line inputs. So how to calculate the select inputs here? So 2 raised to n is equal to m. So n is nothing but the data input and m is equal to select inputs. So there are different types of multiplexer like 2:1, 4:1, 8:1, 16:1, 32:1. So these are the different types of multiplexer. So basically multiplexer handle the n number of input lines, and it uses the log n, that is the base 2 selection lines. So that is m is nothing but the select inputs. So we can say that 2 raised to n input lines and m is the selection lines required for the multiplexer. So here the advantages of multiplexers are simplification of logical expression is not required. So you can implement any combinational circuit with the help of multiplexer. Like suppose you want to implement full adder circuit. So without K-map also you can implement the full adder circuit using multiplexer IC. So it also minimizes the IC count and logic design. So these are the advantages of multiplexer. Now the applications of multiplexer. It is basically used to increase the amount of data that can be sent over the network within the certain amount of time and bandwidth. So that is the main application of multiplexer. So IC for the multiplexers are 74153. We can use 74151 also. So dual 4:1, this is one of the type of multiplexer, and another type of multiplexer is 8:1, 16:1, 32:1. So these are the type of multiplexer. So 4:1 indicate that there are the 4 data input lines and only 1 output line. For 8:1 there are 8 number of data input lines and only 1 output. So multiplexer has only 1 input but it has n number of input. That is the main concept of multiplexer. So this is the block diagram of 2:1 multiplexer. So there are the enable strobe inputs are here and select inputs are here, and Y is the output. So cross line indicates that that is the don't care condition, and the value of don't care may be 0 or 1. So here already we discussed how to solve the full adder example with the help of multiplexer IC. So full adder truth table is like that. A, B, C, in are the 3 inputs for the full adder, because full adder is able to implement the addition of 3 inputs. So that overcome the drawback of half adder circuits. So A, B, C, in are the inputs of full adder and sum and carry are the outputs. Here is the truth table for this full adder. So 2 raised to 3, that is 8 input conditions you required here. 0 plus 0 plus 0, sum is 0 and carry is 0. Suppose the input is 0, 1, 1. So 0 plus 1 makes 1, 1 plus 1 makes 0 and carry 1. So as per this binary addition rules, we have calculated this truth table, and after that with the help of multiplexer we can directly draw the circuit diagram. See, this is the expression for sum and carry. So summation of m indicates that is the SOP expressions. Here for sum expression we consider the output where the output is marked as a 1. So for first, second and this fourth and 7 input the output is 1. So only that terms we have considered here for the summations. And carry, where the output is 1, you can consider those terms. So 2, then you can say 5, then you can say 6 and 7. These are the terms for the carry. And how we can draw the circuit diagram with the help of this IC 74151 or 153. So it has to one IC you required, because see this is the 3-bit truth table. So 2 raised to 3, 8 input conditions are there. So you require 8:1 multiplexer, because you require 8 data inputs. So 8 data input lines, how you can take, that is from D0 to D7. Total number of data lines are 8. So it has only one output, that is sum. Enable stove input signal is there, that is connected to logic 1 or logic high, you can see. And VCC connection is there, VCC and ground. So for the summation, this is the circuit diagram for summation 1, 2, 4, 7. So this 1, 2, 4, 7, these lines are connected to the VCC, that is nothing but the logic high level input, and remaining all the pins data inputs are connected to the ground. And this select A line inputs are A, B, C in. So as per the input A, B, C in, you can change the conditions, you can change the input, and you can observe the output. So for this, suppose you want to test the first condition, A, B, C in are the inputs of this truth table. These are the select inputs, because see data inputs are 8. So 2 raised to 8 is equal to M. M is nothing but the select input. So it is 3. So A, B, C in are the data select inputs. So how we will observe the output here, A, B, C in. Suppose you apply the input 0, 1, 1, 1. 0, 1, 1 for this A, B, C. That time what will be the sum? Sum will be 0. Means that output LED will be off. If you test the particular output, suppose you want to test the condition for 4. When you apply the input 4, so it will give you the output 1. So as per these conditions, the output will be observed. Okay. So again for the carry, you have to take the separate 8:1 IC, and same like this way you can draw the circuit diagram for the carry also. Whatever the carry terms are considered here, you have to connect it to the logic level 1, that is the logic level high or VCC. Remaining all the pins are connected to the ground. And again there enable stove is required, and the select line inputs are also required. So this is the example of cascading. Actually cascading is nothing but when you are joining more than or combining more than one multiplexer, that time it is called as cascading. Suppose you want to implement the 4:1 or 16:1 multiplexer. So how many total ICs you required for the cascading of this 16:1? So total 4 into 4, that is 16. But again separate IC you required for the output also. So total number of ICs you required 5. So see 4:1, 4:1. Again this is total 5 4:1 you required in the cascading of 16:1. Because output of each 4:1 is given as an input to the next 4:1, and final output will be considered from the last 4:1 multiplexer IC. So that is nothing but the example of cascading. So this is the example of multiplexer method. So in the multiplexer method also we can use the design method. So in the design method, suppose we have given the swap expressions, and sometimes the don't care conditions are also given. So design method rules are again there. We already discussed that design method rules in the theory lecture also. So how we can solve that example, just whatever the terms are given in the swap expression, you have to check it very properly, and after that again don't care conditions you have to check. So first in the design method, so what is the maximum input here? 14, means you required here 8:1 multiplexer, because see D0 to D7 total inputs, how many inputs you can take? 16. 0 to 15 are the 16. So first line, that is A bar and A here, mark the input here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So whatever the terms are given in the expression, we have to encircle that terms. So 2, 4, 5, 7, then 10, 14. So after that again don't care condition 0 and 1. So suppose don't care condition is given, that also we have to consider. But in this example we have not considered this don't care condition, because I have just explained you what is the how you can mark that don't care consider. Here we have to consider only this expression, that is 2, 4, 5, 10, 7 and 14. These terms are considered here. And as per the design method table rules, when both the terms are encircled, that time that inputs will be connected to the logic level 1. And when only one term is encircled, that time it is connected to A bar, and first row of that encircled term is connected to A bar, and second row of encircled term that is connected to A input. And if both the terms are not encircled, that time it is connected to the ground. So this is the design table method. So as per this design table, we can draw the circuit diagram. Means if both the terms are not included in the expression, that time that pins are connected, data input pins are connected to the ground. 0 means logic level 0, that is nothing but the ground. If both the terms are included, that time it is connected to the logic 1. Otherwise it is connected to inverted input A and non-inverted input A. Okay, so that is the circuit diagram for the 8:1 multiplexer design method. Next is demultiplexer. Demultiplexer is the opposite of multiplexer. It has n number of outputs and only one input. So that is the opposite of multiplexer. It is also the combinational circuit. It has different types, like 1:2 demultiplexer, 1:4 demultiplexer, 1:16 demultiplexer, and 1:32 demultiplexer. So advantages of demultiplexers are simplification of logic expression is not required here. It minimizes the IC count, as well as logic design is very simplified here. It requires some logic gates in order to realize the Boolean expressions. So the IC for the demultiplexers are 74138 you can use, or 74154 also use for the demultiplexer. And applications for the demultiplexers are multiple output combinational circuits you can design with the help of demultiplexer very easily. So this is the difference between multiplexer, demultiplexer and decoder. So it has many input, multiplexer has many input and only one output line. But demultiplexer has single input line, multiple output lines. And decoder has many input line, also it acts as a select lines. And output lines again same, multiplexer has single output line, demultiplexer has multiple output lines, but decoder has many output line and active low outputs. And formula to calculate the select input, that is 2 raised to m is equal to n, and for demultiplexer it is n is equal to 2 raised to m. So enable strobe input is also required in decoder also. So this is the difference between multiplexer, demultiplexer and decoder. So next concept, that is the parity generator and parity checker. So this parity generator and checker are again the combinational circuit. Parity generator which generates the even parity and odd parity. So it will check the parity word when that parity word is transmitted. So it will check that word is transmitted with the parity bit or not. It will check the parity of that bit. So how will check the parity bit? Suppose you have given n number of bits there, it will check the MSB bit and it will calculate the number of ones and zeros present in that parity word. If it is number of ones are even, so that time in even parity there is no need to add the 0. So even parity bit try to make that parity word with the even, and odd parity bit try to make that word with the odd parity bit. So for example, in even parity generator, before parity checker will discuss parity generator, that is even and odd parity generator in details. So we will discuss in details about the parity checker and generator in the next video. So we have solved the Mentimeter question related to this combinational circuit also. So this is the result of our Mentimeter quiz. Number of questions we have taken for the Multimeter. So this is the result of that Mentimeter quiz. These are the references. Thank you everyone.